Here we're given several absolute value inequalities and asked to determine which of the given values are in the solution set or in the interval. We'll be answering these questions graphically. Remember, the absolute value of a number is a number's distance from 0. So for our first question, which of the given values are in the solution set for the absolute value of x less than or equal to 0? The solution set consists of all the real numbers that are less than or equal to 7 units from 0. So to graph this on the number line, we could start at 0, go right 7 units. We'd make a close point because 7 is less than or equal to 7 units from 0. And then if we go back to 0 and go left 7 units, negative 7 is also less than or equal to 7 units from 0. And all the numbers between these two have a distance that's less than or equal to 7 units from 0. Another way to graph this interval, instead of using closed points, would be to use square brackets. It's the same interval expressed a different way. Again, the closed brackets indicate the endpoints are in the interval. Now let's go ahead and plot the given values and see if they're in the solution set or not. So we have x equals 0, which would be here, which is in the solution set or interval. X equals negative 1 would be here. Yes, that's in the interval or solution set. X equals negative 2. Yes, that's in the solution set. X equals 7 would be here. Because the endpoint is included, this value is in the solution set, so yes. And 12 would be over here to the far right. 12 is not in the solution set. Now, because the values stay the same for the remaining 3 questions, we'll leave our points here and just change the interval. Next, we have negative absolute value of x greater than negative 2. Before we graph this, though, we do want to solve for absolute value of x by multiplying or dividing both sides by negative 1. But remember, when doing this, we do have to reverse the inequality. So if we multiply both sides by negative 1, we'd have the absolute value of x is not greater than, but less than positive 2. Again, we multiplied both sides by negative 1 and reverse the inequality symbol. So we want to determine which of the given values are in the interval, the absolute value of x less than 2, which would be all the real numbers that are less than 2 units from 0. So again, starting at 0, we'd go right 2 units. This time, the endpoint is not included in the interval because 2 is not less than 2 units from 0, it's exactly 2. And then going back to 0, we can go left 2 units. Here, this endpoint is not in the interval though, so it's open point, and we graph the interval between. Now, another way to graph the same interval would be to use rounded parentheses to show the endpoints are not included. So we can also graph the interval like this. Again, normally you wouldn't graph both ways. Different course materials use one or the other. Now we already have the values plotted. X equals 0 is in the interval, yes. X equals negative 1, yes. X equals negative 2 is not here because the endpoint is not included, so no. X equals 7, no. X equals 12, no. Next question. Which of the given values are in the solution set for the absolute value of x greater than 7? So now we're looking for all the numbers on the number line whose distance from 0 are more than 7 units. So starting at 0, we'll go to the right 7 units. This endpoint is not in the interval because 7 is not greater than 7 units from 0. It's exactly 7 units. So we have an open point here, and then we graph to the right because we're looking for the numbers whose distance from 0 is greater than 7 units. Go back to 0, go left 7 units. This endpoint is not on the interval, but all the numbers to the left have a distance that is greater than 7 units from 0. Or we could also express this using a rounded parenthesis here, graph to the left, as well as an open parenthesis here and a graph to the right. Checking our values, x equals 0 is not in the solution set. Either is x equals negative 1 or negative 2. So we're at x equals 7. These endpoints are not included in the interval, so 7 is not in the solution set. Notice how 12 on the far right is, so only 12 is in the solution set to our absolute value inequality. And this last one's a little tricky. Which of the given values are in the interval negative absolute value of negative x less than or equal to 5? The first thing we should do, though, is solve for the absolute value. So again, we're going to multiply or divide both sides by -1, which requires us to reverse the inequality. So we'd have the absolute value of negative x is greater than or equal to -5. Now from here, remember, absolute value represents a number's distance from 0, which we know can't be negative. So if the value on the left is always non-negative, a non-negative number is always going to be greater than or equal to -5. In fact, a non-negative number is always going to be greater than or equal to any negative number. And therefore, the graph of all the numbers whose distance from 0 is greater than or equal to -5 would actually be all real numbers, or all numbers on the number line. You can pick any real number, take the opposite of it, and determine its distance from 0. It's always going to be greater than or equal to -5 units, again because distance is always non-negative. Which means all these values are in the interval or the solution set. I hope you found this helpful.